Greetings and welcome to another VMBlock screencast. In this screencast we're going to continue our journey on learning CosmWasm contracts using Rust. We're going to continue using the CosmWasm book, and we are currently on this section of the book, which is introducing multitest, and we're going to cover this chapter as well as looking at this chapter on contract state. So without further ado, let's proceed. To refactor the tests even further, we can use something called Multitest, which is a library for creating tests for smart contracts written in Rust. You can take a look at it in the crates here, and there's a lot of information about it. But the main thing is that you can think of this a bit like a locally running node, a locally running test node that you might have, say, with Foundry, with Anvil, with Hard Hat node, that kind of thing. Now, I'm not sure at this point exactly how this works, but it does tend to look like it basically mimics the behavior of the blockchain for Cosmos and allows you to write tests such that you would, as if you were deploying the contract on chain and then interacting with it in such a way. So in order to actually do this, we need to first have this execute function, which we annotate with this dead code attribute, because we need this for our tests. So we'll see how this is being used in this section here. If you take a look at the code here, we are now using an address type, and we've got these different types here that we're bringing in to use for our tests. So really, if you follow this through, we're creating this app, which I like to think of this as being the blockchain, essentially. So this is our chain, and we are creating a wrapper of our contract code, which includes these functions that we want to basically test. And we get a code ID, which is the same as if we had deployed the contract on chain. So we call store code, and we use this approach to do that. So that's our first step. So basically we're getting the code using this contract wrapper, which takes the interface, if you like, of the contract that we want to deploy, and then we get the code ID. The next thing that we do is we instantiate the contract. So if you remember, there's two steps we need to do before we can use the contract on chain. It's the deployment and the instantiation of the contract. So that's what this step here does. We call instantiate contract on the app, and we pass in the code ID, the owner, and a few other variables that allow us to instantiate the contract. So now we get the contract instance at this address here, and we can then start to use it. And what we do is we grab the app, and we wrap a query for the WASM smart contract here. So we use query WASM smart to the address. So this is basically, we're saying make a query to the WASM smart contract that's deployed here, and pass in this message body, which is our query message. And so what we're doing is we then unwrap that to get the response, and then the rest is the same. We're testing the response matches what we expect. Okay, so now we're going to add some state to our contract to make this a little bit more interesting, because up till this point the contract just returns a static string hello world when we call it. So we've got the contract, we've got the tests, we've got the abstraction to test the contract as a black box that's deployed to a mock blockchain, essentially. Okay, so we're going to add some state to the contract. In order to do that, we need this CW storage plus dependency, which I've brought into the contract here, and I've set it to version 1.2.0 to get the latest version at the time of recording. Then I've created another file called state.rs that includes this content, which is essentially we're using the address and a new type from the storage plus library called item. And what we're doing is we're setting a public constant called admins, which is of type item, which is this storage plus type. that is a generic type, and the type that we want to use is a vector of addresses. So we then create a new item of this type here using item new and then passing it admins, which gives it a name. Essentially what this is doing is allocating storage location on the blockchain for this contract to store this data type. The variable is constant because in Rust it's constant, as in it's a constant location on the blockchain where we would start to look through for this data. But of course the data itself on the blockchain is read, write and mutable. So we can see this behavior, and of course we're going to write a test for this anyway. Now we also need to add this mod state in our libs so that we basically expose this module. Then in order to set up our contract with a list of admins, we need to create a new message type that we pass into our instantiate function. So if we go back to the contract here, you see that currently it's empty. So inside message rs, I'm going to just add this new message type. I'll just drop it in here. So this is our instantiate message, which is going to have a list of admins in a vector of type string. Then in the contract itself, we're going to update the instantiate method to take this new type instead of an empty type, and when it receives this message, it will basically extract the admins from it. So it's expecting this to be set to some data of type vector, string of a vector of strings. It's going to call some chained functions, eventually mapping the address and actually dropping into the blockchain API here to validate the address, which is useful. So we can make sure that we get a set of valid addresses, and then finally we collect the iterator up so that we can then save that in our storage location for the data that we have collected here, and we respond accordingly. So I'm going to copy this into our contract and replace what I've got here for instantiate, and I'm going to also use this new module constant for the admins. Okay, now it's still complaining about this message not being there. I think that I need to add that. That's here at the top here. I just need to add that. Okay, we should be good now. In fact, I can probably just try to compile this. CosmWasm, and there is an error due to message. That's because of I think it's because of the library. If we look in library here, here this should be of type instantiate message, and that will get that away, and we don't use that anymore. But I guess we need to include that here. Now at this point, if we run our tests, we will see them fail. Actually, it doesn't even build yet. Thought I had fixed that. Oh, that is in the test. Yeah, this should be this shouldn't be empty, it should be this. Yeah, so we've changed this to use the CW multitest as we discussed, and we're using all the interfaces now for properly deploying the contract to our mock, if you like, a mock blockchain here. these different keepers and stuff like that, which is related to WASM, CosmWasm and on Cosmos. The main thing is that we are now using this instantiate message type, and we're setting the admin's key to an empty array or an empty vector. So actually we're not testing this functionality yet, as in we're not testing do we set the admins, but we are making sure that the tests pass. Okay, so now that we've got some state in our contract, let's test this. So I mentioned earlier that we've added the ability to add admins to our contract, but we now need to really be able to query that. So we will create a new struct that it represents a list of admins in our response, and we'll create another trait here in our query message that allows us to query for a list of admins that we have set. So remember, this query message is what we send in. At the moment, up to now we've only had greet, but now we can also pass in this option, which is admin list. And what we do is we can then modify the query function, and it still takes the same query message because we're using this enum, but now we add to the list of arms that the match call will look for in the message, and we've added this arm here to check for the admins list trait, and if we find that, then we call the query admins list function with the dependencies here. So we pass in this into this function here, and finally we define it here on the query module. What this does is it takes the depths and it uses the constant admins, which is set in the contract before, and we call load depths storage. So this basically is how we access storage variables in our Cosmos contract, and essentially what this is doing is really telling that storage what the address is of the storage location to load, and that will then unwrap that and give us the admins, and then we can check we don't check, we basically wrap this in a response struct with the admins and send that back, and that then just gets sent as binary to the caller. So that's all we have to do in our contract, and in order to test it we can just modify our tests to do that. The way we're testing this is we instantiate our contract as before, and we are basically instantiating it without any admins here, and we've got this response of admins and we expect it to be empty. So we instantiate the contract here without any admins, we call the query requesting the admins list, and we expect the response to be the empty vector. Then we instantiate the contract again, and this time we set with admin1 and admin2, and we again query the contract requesting the list of admins, and we expect that to return an admins vector of admin1 and admin2. So I can most likely drop this test into my contract, and it works. So I basically run this test in my local environment here, and the test passes, and it's performing those tests I just mentioned, where it's creating a contract without any admins and then creating or instantiating with a admin set, and it's testing that, and it all seems to be working well. Awesome. And that wraps up this video for contract state and multi-testing, and we hope to see you in the next video where we can continue our journey into CosmWasm. I hope you enjoyed it, and I'll see you in the next video. Thank you.